Welcome to How to Solve the Sudoku Max. Sudoku Max is a variant of the traditional puzzle I created 15 years ago when it first appeared in Scotland on Sunday newspaper. Despite its age, it still seems to cause confusion, so I thought this video would be the best way to explain it to the uninitiated. Like other variants, Sudoku Max adds an extra rule that numbers in the puzzle must obey. The result is a grid with only 18 numbers here, whereas the average Sudoku puzzle has 26 or more. Let's look at the rule, which is in the text above the puzzle, just here. If the 3x3 squares are stacked, each imaginary column must contain the numbers 1 to 9. The 3x3 squares are these blocks of 9 squares. And what the rule essentially means is that if you take together the corresponding squares from each block, for example, the top left squares, here for example, they must contain the numbers 1 to 9. Or the top right squares, and of course there are 9 of them, must contain the numbers 1 to 9, and so on. But the proof of the puzzle is in the solving. Let's begin the proof then using just conventional Sudoku logic. First of all, in the bottom right block, we can see there's only one place that a 1 could go, which is in that slot there. There's only one place that a 9 could go in the right hand block, and it's just there. There's only one place that a 4 could go in the central block, which will be just there. And there's only now one place that a 4 could go in the right hand block. And you can see it's just there. Now let's see how Sudoku Max rules come into play. Concentrate on the bottom left block and where we place the 9s. Now we can see that there are 2 slots left for 9 here apparently, but actually there's only one, because if I were to put a 9 in that square, it would be 2 9s in a top middle square. That's not allowed. So that 9 has to come out and the 9 has to go there. That means we can now easily place a 4 in this square here. Now the top left block, if we draw 9 lines up there, we see apparently again 2 possible squares, but again one of them is not possible because it would mean there'd be 2 9s in central bottom squares. So we'll remove that and put a 9 in there. Now this lets us place I think most of the remaining 1s. Let's look at the top left block again, and although there are apparently 2 squares left for 1s there, this one is not eligible, so there's a 1 that goes there. Continuing with the 1s, let's look at the left middle block. With 2 slots available, only the top one we can't use. So again, we use the bottom one there. Then if we look in the central block, we can't use that square, so one has to go here. At the top, we can't use that square, so the one has to go there. And we'll fill in the last of the ones in the bottom block. There. And you have a 1 at every point of the compass, as it were. There's one in the top right hand corner, there's the top middle, there's a top left, then of course there's the one on the left middle, there's the central one, there's the one on the right middle, and then there's a one bottom left just there, bottom middle and bottom right. That's what we should have with every single number from 1 to 9 when the puzzle's complete. I'm now going to introduce what I'd call a few doodles to help me to solve this puzzle. I'm going to look at the 7s on the left hand side of the puzzle. If I block off squares which can't have 7s, there are 2 squares left in that middle right block. So as an aid memoir, I'll put 2 little 7s in there. They point down in that direction, preventing any 7s going here. So there's 2 squares that can take 7s in there. In the bottom middle block, neither 9 or 5 can go in those 3 squares, but neither can they go in here because of the fact that there's a 9 and 5 in the column. So the only squares that can have 9 and 5 are these 2. 2 squares, 2 numbers mean no other numbers can go in those 2 squares. This enables us to fill the 3 remaining squares with 2, 8 and 7. So 2, 8, 2, 8, 7, 2, 8, 7. Although I can take the 8 out here because obviously there's an 8 just right on top of that square, so that can't happen. Now we come to probably the hardest piece of logic in solving this puzzle so far. It revolves around whether 7 can actually go in this square here. At the moment we see that there could be a 7 or a 2, we've decided. Well, if a 7 were to go into that square there, it would be a top right 7. So there couldn't be a 7 in this square. The only other 7 there could be in that block would be this 7 here. Now, if these two 7s were placed where they are, where would the next 7 go in this block? It would have to be in one of those two squares. Well, it couldn't be in the central one because, look, there's a 7 up here, isn't there? In a central square. So it would have to be in the top left square here. But if it was in that top square, then the only remaining slot for a 7 in the top right block would be here. And that would clash with this 7 here. Therefore, 7 cannot go in this square. And this square, therefore, must be a 2. So I'll make it a 2. There. And I can remove the 2's from these squares. I hope you followed that. I'll try to speed things up now. I'm looking at the bottom middle block. Now a 2 cannot appear in this square because 2 is only available in these 3 squares in the left hand block. Therefore, because 2 cannot appear there, in this column the only place it can appear is at the top. As far as 7 is concerned in the bottom block, it can only appear there and there. As you can see, it is pushing down from there. As a result, if we look at the middle squares all throughout, the only one that 7 can appear in is that one. And that, of course, means that this 7 will have to disappear, and that 7 fills that square. The only top right that can have an 8 is that one. If you just check quickly there, yes, that's correct. So the only top right that can have an 8 is that one. The only top middle that can have an 8 is that one. And the only top left that can have a 2 is now this one. The top middle squares have now almost been filled. We have 1, 2, 3, 4, 7, 8, 9. So 5 must go here, 6 must go there, 3 fills that block, and 6 will fill that line. If we look at this column here, it's clear now that 6 must fill that square, and in the middle column 6 must fill that square and 8 fills the the remaining square. The only middle square left to fill is this one here, so it has to have a 3 in it. That means that there's only one bottom middle square in which a 3 can go. It can't go in this one, it has to go in that one. Now, because 3's have to appear there, they can't go in the top 3 squares there. That means the only 3 available in the bottom right block is there. And that of course means that a 4 fills that block there. And also the only square available for a 4 is there. Now 4 has to go in this bottom right of the top block. You can see that the 4's from other blocks close it off. Now and also 7 has to go here because of the 7 at the top there, closing off those squares at the top. The only place for a 9 now is in this square, in that line. It can't go there, of course, because it would be another bottom left. So 9 goes there. That means that this must be a 5. That must be a 9. And that means in these two top squares, which are both 5 and 9, that must be a 9 and that must be a 5. If you check out all of the bottom right hand squares, there's actually only one place a 6 can go, and it is there. Now that gives us the remaining 3, which has to go there, and then obviously the next 3 goes in there, and another 3 goes up there. This means we can fill that line off with a 6 there. Short work of the rest. 6 will go there, 2 will have to go there, 8 is left over, 7 can go there, which means 7 must go here, 2 must go there, which leaves 5 there, 2 there, and now that this 5 slot is taken, 5 has to go here, 8 has to go there, which means that we can change this to a 7, this to an 8, and then fill off the final 7, 5. Conclude by filling that line with 8, which means that an 8 must go at the bottom, 3 has to go in this corner, leaving us with a 2 there, 2 has to go there, and finish with a 5, and we get the sequence that tells us that we've completed the Sudoku Max. I hope that was enlightening for you. Thank you very much.